get to that and tell you about our presenter. Walt Barlow has been involved in e-learning since 1995 and continues to work with colleges to develop quality online and hybrid programs of study. As the curriculum director for the Automotive Manufacturing Technical Education Collaborative, AMTEC, AMTEC, which is based out of Kentucky Community and Technical Colleges, he is now focused on transforming manufacturing education to better prepare students for careers in maintaining complex integrated manufacturing systems. And I need to tell you that of the multiple flipped classroom presentations that we have presented in this series, I think this is sort of the largest implication in terms of learning on a national level. So let me turn this over to Walt, and I will make you the presenter, and you can take it away.
All right, thank you, Steve.
Okay,
so can you see
your desktop? Great.
Great. You see the clutter.
I see the clutter.
There we go. So get started. I am Walt Barlow, and I work with AMTEC, and we'll go through a little bit of the history of AMTEC and then take a dive into what it is that we've done using SoftChalk to flip the classroom, designed to teach mechatronics maintenance or multi-skilled maintenance. AMTEC. There it goes. So the history of AMTEC is that in 2005, here at the Kentucky Community and Technical College system, we submitted a proposal to the National Science Foundation to determine whether colleges and industry could collaborate around common needs that they had in regards to education and training for multi-skilled maintenance and tool and die maintenance. And we were awarded through the NSF. Then in April of 2005, had a flagship meeting, and you can see there that we had 27 college representatives and 28 business representatives from 4 states to determine, what could be done as a center, and resulting in the establishment of AMTEC as a formal entity. We then went through a planning grant where we worked with our partners to determine what kinds of projects we could work on together and would have the most profound impact on what they felt like were their need for more highly skilled graduates from the community college system. Then in 2006, we were awarded a project planning grant that carried us through 2009, and at which point we were then awarded a 4-year, $5.5 million grant through the Advanced Technology Education component of the National Science Foundation. Since then, we've developed a number of products to be used by our college partners in meeting the needs of their local industry partners. The first and perhaps the most important being the technical standards. We had a psychometrician, Dr. Catherine Manley, who sat down with skilled, multi-skilled maintenance members and asked them what they got paid to do on the job, went through a rigorous Delphi validation process to establish a set of skill standards for the profession. We then had a consensus on consensus meeting that involved 100 to 150 college and industry partners to determine out of all of those skill standards which ones were core to all of their operations. And after reaching consensus on that, we had 100 skill standards, and then worked with that group to parse that out into an associate's degree program with the assumption that that would be 45 credit hours for the technical core. After that, we then began working to develop a curriculum and develop assessments. Since we had standards, now we can make some data-driven decisions that were helpful in terms of being able to understand what industry needed and how the colleges could go about meeting that. As a result, we've developed 13 courses that are subdivided into 57 competency-based modules, all of which employ a flipped classroom methodology. And we also have a number of assessments, 2 comprehensive assessments that act as an end-of-program assessment for a number of college programs in terms of meeting their Perkins requirements for that end-of-program. We've just recently completed the development of 13 end-of-course or topic-level assessments that are used primarily for diagnostics in case companies have incumbent workers who want to advance into skilled maintenance or if they need to level set their skills. We have deep dives into those 13 separate assessments. And then we also have 59 modular level pre and post tests, and we'll see some more of those modular level pre and post tests in a moment. The important part of that being that before a student can begin any one of the MTech modules, they have to complete a pre-assessment to get a diagnostic of what their knowledge is before they begin, so that we can then also determine what kind of an appreciable learning gain has been made by the end. I won't spend too much time on defining the flipped classroom. SoftChalk has had a number of these presentations prior to mine that I've attended. I'm assuming that you all have a pretty good understanding of this. Essentially, students complete digital lectures at home or outside of class, the library, sometimes at their work site, and at their own pace. They then discuss that lecture material with other students and the instructor via online discussion boards or forums. And then whenever they show up for classroom or lab activities, they're active agents. They're working in teams, and they use that time with their instructor to apply the knowledge from the lessons in terms of solving problems that they might encounter that are tied back to the real-world application for skills. We use some pretty standard online tools like learning management systems. We currently host a mobile learning management system of 2.2. And we started off with the SoftChalk Cloud desktop application and have recently migrated to the SoftChalk Cloud, which is allowing us now to map our content into other learning management systems, mainly being Blackboard, with also some investigation into how to map it into the Desire to Learn platform as well. All of our modules are designed to be on an open entry model. It's not restricted to semester-based start dates, and instead it's offered any time, and recognizing that some of the evidence out there for community colleges and technical colleges is that one of the worst things they can ever do is to cancel a class. So we've worked out arrangements with a number of our college partners so that there's always a section open, and even if only as few as one student wants to take that class, they can take it, again, because they're driving that, and then the instructors for those modules have entered into agreements with the colleges about being paid by the student rather than being paid by the course. You can see there, Learn Anytime or Learn On Demand. We here at KCTCS, or the Kentucky Community and Technical College System, refer to this as Learn On Demand, and we have a number of programs of study here in Kentucky that use some of the same strategies that I'll describe here for AmTech, which is that students will start 365 days out of the year. They move at their own pace. They demonstrate mastery. They do the pre-assessment, the diagnostic on the front end, and then go to the post-assessment. And then also we allow for a number of students that can demonstrate mastery on the pre-assessment to advance directly to the post-assessment. And then if a lab's involved, to schedule a comprehensive lab to collapse the time for completion in those modules, which in turn collapses the time to completion for their associate's degree program or certificates. And I think that we've covered everything there. The other thing that's important, and where SoftChalk has been a real advantage for us, is that whenever a student enters any one of these online modules, all of the learning materials are already embedded within that module, so there's no going out to a bookstore, no going out to order, off of any of the different vendor sites. Everything's already encapsulated within that module, so that once they are enrolled, they're ready to go, and there's no waiting. And then the other thing that's important down here is the self-paced or adaptive learning, or differentiated learning, because one of the things that we realized and that a number of people do on a tacit level is that oftentimes for a student, they may understand the material, they may have a background in it, and they can advance on as quickly as they need to, whereas some students may be unfamiliar with the subject matter, may demonstrate that through some poor test scores or poor performance scores, and that allows the instructor then in a facilitated role to target his or her instruction for the students that really need the help rather than, attempting the old-fashioned shotgun approach. Again, we talked a little bit earlier about the modularization. We have the 13 courses that are broken up into 57 modules. Some of our courses are as few as 2 modules. Some of our courses are as many as 7. We used a standard rubric for determining how we subdivided into modules, which was that basically each module would culminate in some appreciable skill that would be of value whenever they entered the workplace. So each module has at least one skill standard that it targets, and that whenever they complete that, they should have improved their ability ripped apart. Here you can see a photograph of an instructor and a number of students around what we designed as our Amtech Integrated Manufacturing Simulator. The simulator uses real-world components of the comparable size and strength as they would find in an advanced manufacturing system on the factory floor. It includes a number of subsystems that include hydraulics and pneumatics, mechanical drives, programmable logic controllers, HMIs or human machine interfaces, robotics, along with basic electricity, and then also some of the latest technologies and safety in terms of safety curtains and end-ons and things like that that are important for students to understand and to know about. So that basically shows, the overview of it. I also want to mention on the fault-based, one of the things that we were able to accomplish too is that in addition to the documentation of the skill standards, we also have worked with our industry partners to document the most common faults or the most common areas where their skilled maintenance workers devote their time. And we have a list of 79 of those most common faults. And out of those 79, we've already begun developing learning-based scenarios around the 22 most common so that students get a chance to practice how to solve those problems using this piece of equipment that we've designed and developed and made available to the colleges. I'm going to have a little shift here out of the PowerPoint presentation to move into our online learning management system. So whenever a student logs in to our Moodle learning management system, this is the view that they would get. And again, pretty standard fare for most of you all, a learning management system, with the same kind of navigational devices and the same kind of features. One of the things that we do early on in the module is to make sure that the students, know what browser we recommend, along with understanding the communication tools that have been made available. So that we have a traditional one-way communication, which would be from the instructor through the news forum, and then one that's more student-driven, and the one where the most time is dedicated, where students can start threads and post questions or comments and get feedback from other students along with their instructor, who takes more of a facilitated role where they're coaching or mentoring. Also, it's very important for us, too, that since we're doing this in an online hybrid format, and one of our primary goals is that all of the instruction is contextualized, which falls back into that flipped classroom methodology. So we start off by showing them a video showing the Amtech Manufacturing System Simulator and emphasizing to them that all of the instruction that takes place within this module is tailored to make it so that they can work on this machine and understand how it works so that they're going to be more proficient and capable of maintaining and repairing the machine should something occur. As I described earlier about the pre-assessments, every student that comes in has to take the pre-assessment. We use adaptive release or conditional release depending on which learning management system you're in, which says that none of the content that falls below the pre-assessment is available to the student until they complete this assessment. Also, as you can see from the notation here, if the student earns an 80% or higher on the assessment, that then provides them with an opportunity to advance directly to the post-assessment. And then if they score an 80% on the post-assessment, then they can schedule a lab with their instructor to come in and demonstrate their hands-on skills. In our close working with our industry partners, one of the things that we took from that is that it was far more important for them that a student be able to demonstrate the hands-on applications of skills to be able to problem solve and troubleshoot with a piece of equipment than it was to be able to perform well on a multiple choice test. But we did at least put 2 screens on the multiple choice side, so we'll do a pre-assessment and a post-assessment that are both aligned to the learning objectives and student learning outcomes for the module that are then aligned to the skill standards to be sure that we've screened them for the conceptual knowledge before putting them in a lab setting. And that's for a number of reasons, one being safety, and the other, also not wanting to waste an instructor's time and to cause, any undue frustration for a student showing up for a lab whenever they're not fully prepared to perform it. At this point, I'll dive off into the lessons. Here, you'll see this module starts with electrical safety, and if I click the electrical safety link, what it does then is it will then open up in a separate window a SoftChalk lesson. And as you can see, if you've used SoftChalk before, you'll probably recognize some of the interface. We did create some customized skin for our SoftChalk lessons so that they're all of the same look and feel, same color schemes, so that students are familiar with the interface. And a student would then advance through the lesson, starting with the objectives that you just saw. And then we tend to, for all of our lessons in a consistent way, we use, on the left-hand side, we provide the narrative or the text for the lesson, and on the right-hand side, some kind of a graphic or a piece of multimedia that helps to illustrate whatever concept's being discussed. As you saw a while ago, we also use some pop-ups, to kind of provide a little bit of extra interactivity to keep the students engaged. And then also, we use the graphics over here, or the larger graphic, to do a better job of illustrating. From the introduction, then we move into fundamental concepts. Here we describe the fundamental concept, but then we also have a flash object over here which actually shows the student, in a graphical way, what's happening with the atom and the electrons. We do the same thing with control of electricity to show a circuit with a switch open, with a switch closed, while providing them with verbiage over here. We also have common symbols, because one of the things that's terribly important for a student to know as a multi-skilled maintenance technician is symbology and schematics. So here they see an earth ground, but then we also want to make sure that when they go into the real world, they understand that typically in a manufacturing environment, you're not going to an earth ground, you're going to a ground bar, which will be located typically inside an electrical cabinet. And we then show a photograph of the ground bar over here, which is actually a photograph of our integrated manufacturing simulator, which is a piece of equipment that we've designed and developed. From there, we go into electrical hazards, and we produce some photographs of burns, trying to make an impact on the students to understand, the need for safety, particularly with electricity. Going through electrical shocks, and then we also have worked with a group up in Michigan, Interactive Training Systems. We had our developers spec out what kind of flash objects they would need, and so here we have one that actually begins to show a student at the different current levels and how they affect the body, and they can click on the values, and it'll show it on the meter, along with describing it down here about how that would feel to them if they were to suffer that kind of a shock, all the way up to 10 milliamps, which would be, a very bad situation for them, but would probably cause them death. And then from there, we do things where we show DC current versus AC current. And again, for beginning students, sometimes it's difficult for them to understand the concept of alternating current. So we try to use, the flash objects to demonstrate that. And try to do it a number of different ways so that they get, multiple opportunities to have a better understanding of how the electrons flow and that kind of electricity. We also provide them ways of doing interaction. Since they're on their own, at home or at the library or somewhere where they don't have an instructor, it's important to keep those students engaged so they can actually do things. So here they would click to show AC current. That's on the one hand, they see the alternation of the current. They're told that it's 1/120th of a second. But then below that, they also see a sine wave, which is the wave that sort of been represented on an oscilloscope, which is an important instrument for them to understand. And it's important for them to understand the sine wave and what the differences in the sine wave would indicate if they were actually making some kind of measurement in the field.
Well, let me interrupt you. I think your headset may be moving a little bit away from your mouth. It's getting a little harder to understand you. So I don't know whether or not your headset has moved.
Is that better?
That's much better. Thanks.
Great. And I apologize, you all. I'm using a headset that I've never used before. So, and again, as we advance through the lesson, you can see more of the same, which is basically trying to show what they would see in person, along with how that would be represented on a piece of electrical test equipment. We go through electrical shock, treating electrical shock victims, and then we get back to the more interactivity that we were able to put in here with the SoftChalk tool, and it allows students to practice as often as they need. Again, one of our concepts being in mastery learning is that some students learn this quickly, some may take more time, and if they have all the time and they're willing to continue to practice, we should let them. So here they would drag and drop to identify the steps for treating an electrical shock treatment victim. And again, it continues on with arc burns, electrical safety precautions, and again showing an electrician measuring electricity in a cabinet. And that's actually a low voltage cabinet, which is why he's not gloved up or sleeved up. And then we go to things like fuses and electrical circuit breakers, We show things like what would happen to a fuse if it overheats. So again, the student gets to see, what happens beyond just telling them about it. They actually see a fuse burn out, or they get to see what happens to the insulation on a wire as it overloads and overheats, and the potential for fire. And then just showing them these are what the standard kinds of fuses look like. Also things like resetting the breaker, just to provide some visual appeal to the lesson. And from there we go to short circuits. We talk about excessive loads and show students, like whenever you have too many things in the same circuit, what happens, and we show it both in terms of what would happen if you had all these different things plugged into one circuit, along with what that looks like if you were measuring the amperage with a piece of electrical test equipment, all the way down to where it would overload and something would trip. And again, showing them what it looks like whenever it's tripped, the fuse burns out or the circuit breaker clicks to off. One of the other things that we do too, I want to advance kind of a few slides forward because I think you can see, what we do there. Again, some of the AC current flow, again, trying to help students to understand, because it's often very difficult to understand, the way that all the way from the power source to the appliance, while the excess is then flowing back into a ground. Again, trying to find ways of making sure the students understand, how that all works. And I'm going to advance a couple of slides on forward, and then we have the self-assessment. And one of the things that we felt like was terribly important, especially in a flipped classroom where the students are getting their initial feedback in isolation, is that we provide them with that kind of feedback instantaneously, just in time. So as the student completes one of these quizzes, using our SoftChalk tool, and I'll answer just a few of them, and then I'll bounce back out so you can see what the results is, that they can take the quiz. They can take it as often as they'd like. And then whenever they go to check answers, their score follows them around as usual, but we also provide them with the correct answers. And then that helps them to reinforce, whatever kind of learning took place. And also they can see, like for me, I got a 2 out of 30. I would know that I need to go back and review. The other thing is that by using the SoftChalk Cloud tool, we're also able to provide this performance data for each student to the instructor without having to invoke a scoring player. So both the student and the instructor get that feedback. For the student, it allows them to have that metacognitive awareness of their own learning, where they're more active, and again, recognizing that if they score poorly, they need to review. But then also, the instructor has that in real time as well, and so the instructor can see that if a student is scoring a 2 out of 30 on the formative assessment at the end of a lesson, that's probably a student where they want to target their intervention, whereas for the student that might come through here and make a 28 out of 30 or a high score, like well above an 80%, it might let that student move on without, having some kind of an intervention there. To show you another one of our lessons, the basic concepts rather than just the electrical safety. Again, same interface. And then a student would advance through here, and now we're going to start talking about structures of atoms and ions. One of the things we've done too is that we've used open educational resources, by providing some links back to the Wisconsin Online that was funded out of the NSF, into making use of what was already available. And then we go into basic electrical circuit components and voltage and current, and again, at various points in here, providing students with an opportunity to interact with the lesson as well, so they can switch to turn the light on or off, to see what happens whenever from a DC circuit, how the electrons flow in a single direction. Going through resistance, conductance, power, and then allowing them to now do a self-assessment, same format as before, using multiple types of items, everything from multiple choice to matching items. We also include short answer items in here where they calculate the values of circuits, and then to a retest, where again it gives them multiple opportunities to assess their own knowledge or understanding of the subject. Once a student has completed the lessons, and what we've done is by working with our industry partners and our developers, we had them punctuate those lessons with labs, And so what would happen is the students would complete these two lessons, lessons 1 and lessons 2. Whenever they complete lesson 2, they then contact their instructor to schedule the lab. Or if they happen to be moving as a cohort, then the instructor simply tells them what time the lab is going to be conducted, and then they come into the lab area. The first thing we do is provide them with a description of the lab. So that says, here are your objectives, these are the materials you're going to need, and then to provide an introduction to set the stage about why they would even do this to begin with, and then tell them what the steps are that they're going to have to perform. And so now they understand that. We also provide them with a printable rubric that then shows them how they're going to be scored whenever they get to the lab. As most of you all know, in the flipped classroom, it's absolutely essential that you establish what the expectations are for the student. So we've explicitly outlined, or not outlined, but detailed step 1, step 2 through multiple steps, identified how they'll be scored, and then for all of our labs, because this is skilled maintenance and manufacturing, all of our labs have 4 items consistently, whether it's in blueprint reading or programmable logic controllers or hydraulics, is care and use of tools, work attitude, self-confidence, and knowledge of the job. And again, those things are very important and have been very difficult for folks to measure on the manufacturing education side, and that the employers say is terribly important to them, about those kinds of behavioral traits beyond just technical expertise. The other thing that we're really proud of in terms of collecting data so that we can make better decisions and understand where students are getting it and where they're getting tripped up. Also about being able to assess the effectiveness of our curriculum is that we've created online rubrics. And so this would be the feedback as a student that I would receive from my teacher. And so I would get that rubric back. The areas that are highlighted in green are my score. And then over here on the right-hand side, there is narrative feedback from the instructor based on his or her assessment of my performance. So here, I got a great job. Down here for the sketch the location of the emergency power off button. I got a review machine documentation note. Or down here, about understanding the importance of material safety data sheets. And then all the way at the bottom, we then provide an area for the instructor to put overall feedback for the lab, along with what that student's score would be in the lab. Again, recognizing that the kind of feedback that we're trying to provide, the kind of coaching that we're trying to provide, and that in some ways brings about a certain element of chaos, but then this brings us all back into a data-driven format where we can make we can analyze the data and then take appropriate actions based on student population numbers. Also, all this data is available both for the local instructor and for us through a centralized data collection system. So what I showed you there was really more of our materials that we created using the SoftChalk desktop application. Since then, we've migrated a good bit of our content over to SoftChalk Cloud. Again, trying to find ways of doing a better job of distributing this content to multiple learning management systems so that it can be embedded within the native learning management system interface at each of our colleges. So as most colleges have already done, they have a fully integrated technology infrastructure with their student information system. Once a class is entered and once an instructor is identified and once students enrolled, it automatically populates into a learning management system. So for us, it would be better to map our content into those native learning management systems and not ask instructors to have to go out and manage students in a separate system. So here you can see my cloud items. We've currently got about 172 in the cloud. By the time that we're done, we'll probably have about 300 lessons and labs over here. And whenever they come in, I'm able to create the score center, which again, as I described before, is a centralized data collection system that maps the score both to the LMS gradebook and into the central score center so that the instructors have the information that they need so that they can intervene just in time and appropriately for those students that need the intervention. And we collect the data so that we can begin doing data analysis or learning analytics that will be important for us to determine what changes need to be made in the curriculum, potentially looking at the differences between populations at school X versus school Y, and then investigating what one instructor or one program may be doing differently than the other, so that any kind of innovation or any kind of best practice or promising practice that may be taking place there can then be shared across all of those schools. Because like I said earlier, we now have 30 colleges who are members of AMTech, and then we have essentially every major automotive manufacturer that has operations in the state that are working with them. So one of the things that we want to do is to, one, create content that is laser aligned to the skill standards that have been validated by industry as a need that they need, but then also to look at the individuality of each of one of those instructors or programs to find where successful strategies are in place, and then to be able to share those out with the rest of our members. One of the other things I wanted to share with you too are the fault-based scenarios. And this is where it's really terribly important, is that our labs are oftentimes, not every one of the labs is a fault-based scenario, but we're actually in the process now of converting all of them to fault-based scenarios. But what we've done is with our simulator that you see there in the picture, and actually this picture is pretty interesting too in terms of flipped classrooms or facilitated learning. It happens to be a photograph whenever the instructor who is squatting down there to the left-hand side of the simulator was telling the students about how to adjust the calibration of the hydraulic system. And so while he was talking to them, he was turning the knob, and it so happened that while he was doing that, he got it way out of whack. And then he had to figure out how to get it back calibrated. On the one hand, he at first started panicking because he felt like, you know, he's supposed to be the expert, and now he's having to work hard to get it back to where it ought to be. But then he realized that he was actually doing what might be called a cognitive apprenticeship with those students. And so they got to watch him not pretend to adjust the machine or not pretend to teach them a lesson, but they actually had the chance to not only watch him, but to help him to get that machine back calibrated the way that it needed to be. The fault-based scenarios with this machine involve having the students come together as teams. Since almost all of the major automotive manufacturers or advanced manufacturers now use teams or skilled maintenance teams, it's good for the students to also learn how to practice working with others, which is a difficult thing to do if you've never had the opportunity. So we bring together a team of from 2 to 4 students. We then say, you're now going to play a role. You're maintenance. You've just received a phone call, and the operator says that the machine won't come on. And so the students then go to the machine. Well, now they know that if they're in an electrical module or an electrical course, that they're probably going to, you know, focus their troubleshooting efforts on the electrical. And we want it that way because it helps to kind of frame things out so that they see that it's a subsystem integrated with other ones. But you know, they need that to be narrowed down for them so they don't have the whole wide world of possibilities in front of them. But then we also have capstone scenarios where those students would come to a machine. They wouldn't necessarily be in an electrical course or in a hydraulic course. They would be in a troubleshooting course. And now as a team, they have to go to a machine and troubleshoot it exactly in the same way that somebody that's working in the field would. The instructor typically plays the role of an operator, and we typically have someone else play the role of a supervisor or a manager in some of those scenarios. The student would be called to the lab, and so what's happened now, they've done online learning by themselves. If they've had questions or discussions, they've had those online. They come to the lab. They're presented with a learning scenario. They show up at the machine to fix whatever's wrong. The instructor plays the role of an operator, which then requires that the student ask, you know, the right kinds of questions of the operator. You know, what did he see or what did she smell? What was the last sound that was heard? And then they'll go through a standard troubleshooting protocol that they've been taught. And what that does is it's kind of like a systems approach or closed loop learning, where they recognize that this is how the machine should operate whenever it's effective, whenever it's operational. Here's the background knowledge that a person would need to know in order to understand that system and in order to understand how to resolve it. There's a troubleshooting protocol, you know, which are habits of mind, that each time that you're presented with a troubleshooting situation, these are the phases or steps that a person would go through in order to resolve a problem. They then go through that resolution process. Then they confirm that it's repaired. And then after they've confirmed that it's repaired, then they do the same thing that maintenance workers would do in the field, which is to document that repair, but then to also go into a double loop learning mode, which would say, if this machine has broken down in this way multiple times within a certain time frame, what could we do differently to make it so the machine would not break down as often, so that they could then increase the efficiency and productivity of the piece of equipment they're responsible for maintaining or repairing. We're very excited about the work that we're going to do in those fault-based scenarios, using the body of knowledge around problem-based learning scenarios, or PBL. Even though we're using those in some areas, like I say, we have plans for expanding that out and of using SoftChalk Cloud as the tool by which we will write those scenarios and present those scenarios to students, so that they have a firm understanding of what the expectations will be for them whenever they arrive. They'll know what materials or tools are going to be needed before they arrive, and they'll also have the opportunity to review like troubleshooting protocols or background knowledge through that kind of an interface.
Well,
so hopefully,
it sounds like you're about to wind up, because I was just sort of giving the 2-minute warning if you're not.
I'm winding her up right now.
All right.
So what happens there is that by one, leading students through and giving them the flexibility and the opportunity to do what would normally be lecture at their own time and at their own pace, to provide the instructors with the tools for intervening for those students that need it, and then bringing those students into a lab environment that's an integrated systems environment. The students can then apply that knowledge in a facilitated way with the instructor, either one, simply observing and allowing the students to go through the troubleshooting and maintaining process themselves, or to intervene and to coach as necessary. And we think that that's going to dramatically improve those students' performance whenever they make it out in the field. Thank you.
All right, thank you. Well, I'm going to launch one last poll as we sort of wind this up, but we have several really good questions, and I want to encourage people as they're responding to this poll to also go to the Q&A box, and your last chance to ask questions of Walt to follow up. One thing that, and while they're responding to this, one of the questions that came on early was about the placement rates. From when they complete the program to employment, average earnings, retained employment after 90 days, or whatever that time frame is. Could you talk about employment opportunities and data?
Well, the data suggests that there are a number of skilled maintenance jobs out there that are unfilled, and that the employers have identified, the skills gap or the skills shortage as the reason why those positions aren't filled. And we work closely with them in career pathways to identify how to get those students through those programs. For students that do graduate from a 2-year associate's degree program in industrial maintenance or mechatronics maintenance, here in the Kentucky area, they tend to start off in the mid-50s in terms of their earnings, with the possibilities for some of those folks that within 10 years, some of those skilled maintenance workers who advance into being a team leader are making in the $90,000 to $100,000 range. The other thing is that, so it's for a 2-year degree, that's pretty impressive. The other part of this is that for the employers, different partners have put together different programs with different criteria, for admission into the program or for hire. So it's kind of hard to speak to a one-size-fits-all model. But one of the things that they do is they use the MTech assessment as an initial screen to determine whether they need to go and get some additional education before they take their real employment screen, so that we're now in the process of collecting the kind of data that would help to indicate what type of student, what kind of demographic markers would indicate somebody who has a likelihood of success, along with which kind of demographic markers might indicate there might need to be stronger interventions to help that student to be prepared to go into that employment opportunity.
Yeah, well, the fact that you are so active in your intervention is very impressive. Let me share the results of the poll. And so half the educators are teaching in a traditional face-to-face classroom, only 20% in the flipped classroom. And of course, our data of all the the management administration is not surprised that a third of the audience do not teach. Interesting data. So let me hide this and get to the second, to additional questions. There was a technical question. One of the things that SoftChalk does so well is it makes it easy to bring in other kinds of content. They noticed that you brought in a lot of what they described as flash objects, although I'm not sure they were really flash objects. Could you just describe how they are created and built and what your role is and where they came from?
So we do it. Those are flash objects that you saw, and we actually had investigated using HTML5 instead, but ran into some barriers there. But we use a group called Interactive Training Systems out of Fenton, Michigan, to do the actual flash development. We have industry partners who work with our module developers who tend to be college faculty, and so the college faculty member and the industry partner in their discussions determine what would be best to animate. After they've determined what's best to animate, then they write out a storyboard that describes in detail to our developers what needs to show, what needs to move, what needs to be interactive, and then they develop it. They provide it to us. We go through a confirmation and validation stage, push back to revisions if needed. Then they provide it to us, and then we plug that into a SoftChalk package file.
Great. One of the questions I think you need to maybe clarify, because I know the answer, is the face-to-face lab located, you saw on the slides, at a centralized location or at multiple sites?
It's at multiple sites. There are a number of different schools that already have that simulator installed at their campuses. The ones that come immediately to mind for me are at Bluegrass Community and Technical College in Georgetown, Kentucky. They're at the Toyota motor manufacturing plant, but they also have their North American Production Support Center. There's also 2 of those machines at different Nissan locations. One is in Smyrna, Tennessee, where the Tennessee Technology Center at Murfreesboro teaches against it, and then the other is being delivered to Canton, Mississippi, where I believe it's Holmes Community College will be using it. We also just recently had a number of colleges that are members of AMTech who submitted a Department of Labor grant that was funded, and they all now are in the process of ordering those machines, and as I understand it, I think 13 of those are being built and will be shipped out to schools that range from Michigan all the way down to San Antonio, Texas.
Right. Now let me reemphasize the national nature of this grant, which is, and so I imagine that those machines will increasingly become a nationwide locations.
Yes, and one thing I'd like to mention also is that we entered into an arrangement with Fanuc Robotics, which is the world's largest robot manufacturer, and so they're the official builder of the machine now, and as part of that, they're creating simulation software where it'll have the same functionality in a virtual environment as the physical machine, so that if you have a group of 12 students and they're rotating through their labs in groups of 2 or 4, the other students, if they're in that lab area, can actually be manipulating the machine in a virtual environment, so that it gives them some practice time before they're actually there putting their hands on it. And in the situation that could either 1, be potentially dangerous, or 2, just be a bottleneck in terms of the number of students that can work on the machine at one time.
Yeah, I think your headset may be moving away from your mouth again. So one of the questions, if a student does not do well on their self-evaluation and reviews the material, is the same exam administered, or do they take another one? What is that process like? Because I know there's a variety of ways you can be routed through the entire process.
Right. So at the lesson level, the ones that I showed you, those are separate assessments. So there's a self-test, and then there's an assessment. And in some situations, we have as many as 3 separate assessments that cover all of the learning objectives for a lesson. Not all of them do. Some of them, it's just basically repeating the same thing. On the pre-assessment, they can only take that once. So whatever score they earn on the pre-assessment for the module, that stands. On the post-assessment, it's actually the same assessment twice, but then we enforce a time delay between the first attempt and the second attempt, because when we built this, again, if you think about 12 courses, 13 courses, 57 modules, what kind of an item bank would have been required for us to have created duplicate assessments for each one of those. We have not accomplished that yet, but we have plans for continuing assessment item development so we can actually deliver a separate assessment that is, again, aligned back to those same learning objectives and skill standards. But, currently it's the same assessment twice on the post with a timed a forced time delay to try to minimize any kind of halo effect.
I see. Okay, I think we have time for one more question, and this I think needs a clarification. It says, if the entry to the class is open and can be entered at any time, how do they schedule the labs?
It's very difficult. So one of the things that happens is that most of the schools have traditional time-based delivery, so that the labs being actively used. But then what some of the schools have done is that they've blocked out time in that lab whenever it's available as a first-come, first-served basis. And so students show up. A better system is where they actually publish a schedule to the students about when that lab is available. Students then sign up for the lab. They're then able to look to see what kind of a demand they have for specific times, and then how to manage the students that come to the lab to complete whatever kind of a scenario has been presented to them.
Okay, well, let me take the desktop back and say thank you, Walt. I think some other questions may come in. And remember, this webinar is being recorded so that you'll be able to review this material that way. And we're going to take a look at some of the questions, and if there's a few that we think we can answer offline, we'll get back to you. But for the moment, we've had a couple of folks from NISOD sitting quietly in the background, and Larry Miller, who is the director over there for NISOD. Larry, tell us about NISOD and about your annual conference.
Oh, I would be glad to do that, but first I'd certainly like to compliment Walt and his team on such an amazingly deep and thorough instructional program. Industry standards are so nice when they can drive it, but that also takes the cooperation of your industry partners, and then it takes a real team to put together something as sophisticated as this, and I just want to compliment Walt on a really fine job. Now, NISOD, which stands for the National Institute for Staff and Organizational Development, is a membership organization. We're about 35 years old, and we are focused upon community, technical, and junior colleges. We are part of the University of Texas at Austin College of Education, and we operate as a membership organization. And our kind of big event that we have is coming up, and that is our International Conference on Teaching and Leadership Excellence. Many people just refer to it as the NISOD Conference. It's always in May, this year the 26th through the 29th, and it's always in Austin, Texas. And so we would certainly welcome people that are participating in this webinar, or ones that are going to view it as an archive, to consider coming to our conference, finding out more about our organization, NISOD, and you can do that at our website, which is www.nisod.org, and you'll find a lot of information. Now, this medallion that you're seeing here is actually a really significant award. It's sort of like a Lifetime Achievement Award for people that teach in the two-year college world, and that is the NISOD Excellence Award. And to date, we've had 24,000 recipients of this award, and it's a very, very significant award. And we have a big ceremony to kind of kick off our conference on the 26th of May, right here in Austin, Texas. So hope you can join us.
And indeed, I will be there. Let me let me remind you that this is the third in a series of webinars on the flipped classroom. We've done from specific courses like chemistry and public speaking to this, a nationwide effort using the flipped classroom technique. So we're very excited because all these have been recorded. The archive is available. This one is being recorded, and you will all get an email tomorrow with a link to the archive. And currently, the archives are already available for the first two. And I encourage you to consider looking at, if you haven't already, registering for the fourth and final series, which is going to be a discussion about why it works, what various theories are in terms of teaching and learning and what those are and how those relate to the effectiveness of the flipped classroom. But I told you that there's many of you who just really are first-timers who don't really know about SoftChalk. There's a lot of ways to learn more about it, and I encourage you to take a 30-day trial of SoftChalk Cloud, which is our newest offering. And one of the reasons that the AmTech program can be as effective and efficient as it is because it uses cloud to not only create but to store their content. We have a bunch of webinars, we have training videos, we of course have newsletters and Facebook and Twitter accounts, so come and join us and learn out more about us. And finally, if you want to know more, I am going to leave this information on the screen for a few moments, but rest assured this information will come to you in an email tomorrow along with that link to the archive. And so if you want to connect with us directly, there's Walt's email as well as the AmTech website and information about SoftChalk. And if you want to learn more about SoftChalk, that's the email address. If you want to contact me directly, you have a question for me, that's my address. You want information about NISOD, you can go to info@nisod.org and someone there will pick it up and get back to you. And Walt, really a wonderful presentation. I'm very excited about the work you are doing, and I think we're going to, work with you some more to sort of publicize the kind of work you're doing. So I'm really delighted. It's an exciting project, and I am just really impressed with how you got all the auto industries involved to work with you. That was quite a feat, and I compliment you on that.
Thank you. It was a pleasure being a
So, are there any final goodbyes to today? Walt, you want to do a final salute, and then Becky and Larry?
Thanks, you all. I really appreciated the chance to share what we've been doing at AmTech with the SoftChalk and SoftChalk Cloud tools. And thank you, NISOD, for hosting and for supporting the work that's been done here.
Yeah, and this is Larry at NISOD, and I just want to thank Walt again for doing a marvelous job. Also want to thank SoftChalk. SoftChalk came up with this idea for doing the Flipped Classroom series. I think Flipped Classroom is one of the most significant learning strategies that's around, and I think this webinar series is giving us a really in-depth look. I mean, there's a lot of variety in the 3 we've had already, and I think this next one coming up will be a great capstone for the series. So thanks, SoftChalk.
Yeah, you're more than welcome.
I think Larry said it all. So, Steve, thank you, and Walt, fabulous job. And I really do want to come take one of these courses. I think it looks like a lot of fun.
Yes, all those big, scary electric machines. Yes, right, a lot of fun.
Coming from a technical college background, so
yeah, that's true. That's true.
I think it does look fun.
Different than mine. Right, right.
Right.
Okay. Well, thank everyone.